crucial. That's the origin of the word crucial, right? It's the one that tells you which way to go. Okay, so here is Isaac Newton, and he's holding something. Can you see what he's holding in his hand? I'll give you a hint. It's a prism. Why is he holding a prism? Because that was his crucial experiment. Right? And here's his diagram of that experiment with a prism in it. He called it the experimentum crucis, taking the word from Bacon. Okay, so light came in through a hole in the window, through a lens, and then got bent and dispersed into the different colors. So you get a spectrum here on this thing, the different colors. Okay? Now, there's the question, how does the prism make color? Hooke and Descartes thought that light was a train of pulses, and as it goes through something like a prism or as it reflects from a thin layer of oil on water or something like that, that it changes the timing of the pulses and therefore changes the color, right? But Newton thought that the colors were pre-existing and the prism just separates them. And this was his crucial experiment to decide between those two theories. You see what he did? He drilled a hole through the board and let through only the red light and put a second prism there. Right? And he wrote here 3 times. He wrote it here, and also here, and also here. Nec variat lux fracta colorum, which means the broken light does not change its color. Right? So this proved to Newton, at least at that time, that light is a substance, not a train of pulses. What do you think of that proof now? Do you think light is a substance or a train of pulses? But at least you can see that in terms then, that was a crucial experiment, a really important experiment. And that's the kind of experiments we'll try to talk about in the course. Experiments are indispensable in organic chemistry. It's an empirical science based on observation, and that's why you have to take the lab. But so is logic. Now, that was number 3 and number 4 are the ways of knowing. Logic is important too. So believe what I tell you here only when it makes sense to you. Don't just cram it in. Make sure it makes sense. But what if it doesn't? Okay. Now here's how to succeed in Chem 125, and we'll take as our model science student Samuel Pepys. How many people have heard of Samuel Pepys? Have you heard of him as a scientist? What did you hear of him at? What do you associate with Samuel Pepys? Right in this period, right in the heart of the science growth. But what you know him for was his diary, which tells all about life, everyday life in Restoration London. Okay? He was actually as a 16-year-old present when Charles I was beheaded in 1649. Now, what's the connection? Do you know where this is? Has anybody been there? Dixwell, Gough, and Whaley Avenues. Those are named for 3 of the 50 judges that condemned Charles I to be beheaded. And they were the only ones that lasted very long after the Restoration. And they lasted because they fled to New England and were hidden on West Rock. All these roads are heading west toward West Rock. Okay, so that's tie into the same period. But anyway, he got his BA in Cambridge in 1654 and a master's in 1656. And he got a good job. He became Clerk of the Acts for the Navy Board, which meant he was the guy that purchased everything for the Royal Navy. All the rope, all the tar, all the lumber, and so on. And on July 4th, 1662, I mean, it's the 4th of July, but it's more than 100 years before that became relevant, right? He writes in his diary, "By and by comes Mr. Cooper, mate of the Royal Charles, of whom I intend to learn mathematics, and do begin with him today, he being a very able man, After an hour's being with him at arithmetic, my first attempt being to learn the multiplication table, we then parted till tomorrow. So here was the guy doing all the purchasing for the Royal Navy, and he didn't know multiplication, let alone division. But he worked hard at it. July 9th, 5 days later, he's up by 4 o'clock and at my multiplication table hard, which is all the trouble I meet with all in arithmetic. He can do the other things pretty well. Okay? July 11, up by 4 o'clock and hard at my multiplication table, which I am now almost master of. Christmas, right, so 6 months later. So to my office practicing arithmetic alone and making an end of last night's book with great content till 11 at night, and so home to supper and to bed. Or a year later, so he was motivated and he was diligent. That's good. Okay? A year later on a Sunday, I below by myself looking over my arithmetic books and timber rule, so my wife arose anon, and she and I all the afternoon at arithmetic. And she has come to do addition, subtraction, and multiplication very well, and so I purpose not to trouble her yet with division. Right? So he worked with a study partner, and that's crucial. And Isaac Newton. Does anybody recognize this book? Right? The Mathematical Principles of Science, of Natural Philosophy. But there's an interesting thing on the title page. Samuel Pepys is the one who gave permission to publish that book because he was the president of the Royal Society. Now, 6 years later, Pepys encountered a problem with dice. The reason was he went to coffee shops every night for dinner, and they'd gamble, right? And people proposed various kinds of bets, and he couldn't figure out this one, so he wrote Newton for help. So this was the problem that he wrote to Newton in 22nd of November. So A has 6 dice in a box, and he has to throw a 6 by throwing it, right? B has 12 dice, and he has to fling 2 6s. And C has 18 dice, but he has to get 3 6s to win. The question, whether B and C have not as easy a task at A, at even luck, that is, if the dice aren't loaded or anything, who has the better bet? How many people think that it's the same? Don't be shy. How many think it's A? How many think B? How many think C? How many don't really have any opinion at all? Good, that wins. Okay, so he wrote this letter to try to get help on his bets from Newton. And Newton replied 4 days later, what is the expectation or hope of A to throw every time 1 6 at least with 6 dice? So you get 2 6s, you still win, right? That wasn't clear in the original statement. So he says if we formulate the question that way, it appears by an easy computation that the expectation of A is greater than B or C. That is, the task of A is the easiest. There's the answer. So Pepys replied on the 6th of December, you give it in favor of the expectations of A, and this, as you say, by an easy computation. But yet, I must not pretend to so much conversation with numbers as presently to comprehend as I ought to do all the force of that which you are pleased to assign for the reason of it, relating to their having or not having the benefit of all their chances. So he wasn't ashamed to admit that he didn't really understand. That's crucial. Okay? And therefore, were it not for the trouble it must have cost you, I could have wished for a sight of the very computation. Can you show me how to figure it out? And he wanted that because somebody might change the terms of the bet and then he wouldn't know. He wanted really to understand. He insisted on proof. So this is 2 of the pages from Newton's correspondence of the letter that he wrote in response, and you can see that Pepys certainly got more than he had bargained for. So to compute this, I set down the following progressions of numbers. So you can go through all this, and you get complicated quotients here.